Yes.
Okay, awesome. So let's continue talking about inverse function. Number 33, we have f and g. F is x squared, but here the domain of the square function is not all real. It specifies the domain is x bigger than or equal to 0, part of the parabola, not the whole parabola. G of x is the square root function, square root of x. And we need to determine if those two functions are inverse of each other. We're going to use the definition to make the decision. To prove f and g are inverse of each other, we need to consider f of g of x, also g of f of x, to see if they are both x. All right, so let's see the first one, f of g of x. This composite function has inside function g, outside function f. Remember, when we process a composite function, we get rid of the inside function first. Inside function g of x is root x. We have f of root x, right? And then we're gonna get rid of function f. How does function f work? Function f is a square function, so the output is always equal to the square of the input. Now the input is the pink, right? Whatever inside the parentheses. So the corresponding output would be the pink is raised to the power of 2. And the pink here is root x. Root x to power 2, root x times root x, we know equal to x, right? When x is bigger than or equal to 0. So we have the first equation, f of g of x. This means g is the inside function, so machine g first. F is outside function, so machine f after. When you give the unzapped line any input which is bigger than or equal to 0, and the corresponding output after the unzapped line is still x. That means whatever machine G has done to the input x, machine F has reversed it. So we proved f of g of x equals x. That means we proved f reverses g. We shows f reverses g. The other direction, we're going to look at g of f of x. G of f of x. Inside function f, outside function g. Get rid of inside function first. Inside function f of x is x squared. Let me change a different color. I use blue. So the input of function g is blue. Okay, it's blue. Function g is the square root function. G of x equals the square root of x. So the output of the machine g always equal to the square root, the principal square root of the input. So here we have g of the blue equals the principal square root of blue, which is x squared. Because x is bigger than or equal to 0, this condition is important. Okay, this condition is important. Only when x is non-negative, only when x is bigger than or equal to 0, this expression equals x, all right? Otherwise, actually, this is a pretty important formula. If you want, you can include the right here. Square root of x squared equals absolute value of x. When this way, when x is bigger than or equal to 0, absolute value of x is itself. When x is less than 0, absolute value of x is its opposite. This is a formula, okay? Not very important in this case, but we do need to have this condition met in order to write square root of x squared as x, all right? Square root of x squared equals x when x is bigger than or equal to 0. In this question, number 33, variable x only assume non-negative values. X is bigger than or equal to 0. So the second equation shows function g also reverses function f, because we just shown when the input x is bigger than or equal to 0, go through function f and then go through function f, x comes out. It does not change. That means whatever machine f has done on x, has done to x, machine g reverses it. So the second equation we show g also reverses f. Since the two functions reverse each other, the two functions are inverse of each other. So we use the definition shown f and g. By the definition, you can say by the definition.
Hi, Betty. I have a question.
Yes, please.
Did you get my email last week on why I had to miss class on Tuesday?
Hold on. I'm pretty good at responding emails. Did I respond your emails?
I don't believe so.
I can look at it again. Normally I don't miss, but sometimes when I have a lot emails, I might. Okay. Is that very important? Can I respond that later?
Yes, you can do that.
Yeah.
Thank you.
No problem. Let's see. Okay, you're right. Actually, I saw your emails. It's January 30th, right? Okay, I'll look it up later. Thank you for letting me know.
Yes, thank you.
No problem. So if some of you missed the roll calling, same as always, email me after. Try not to be that, just to join a meeting on time. I really have a lot of emails every day. Okay, let's continue on the note. So we proved f and g are inverse of each other. And the second part, we're going to graph the two functions. We already know the two functions are inverse of each other. We want to know the relationship between the two graphs. All right, we want to know the relationship between the two graphs. So this is the rectangular coordinate system. This is the orange in the middle. We're gonna graph the function f. Function f is the squaring function, but only the part in quadrant 1. Only when x is bigger than or equal to 0. So this is f of x. G of x is the square root function. Do you guys remember the curve that represent the square root function? It looked like, I can change the blue here. This is g of x. Okay, this is g of x. And this point, the intersection of them, is 1, 1. 1, 1 satisfies both functions. And do you see the relationship between the two graphs? Since x is bigger than or equal to 0, both graphs only appear in quadrant 1. If I use a dashed line to bisect quadrant 1 and quadrant 3, this is the bisector of quadrant 1 and quadrant 3, y equals x. All right, and the red graph, the red curve and the blue curve, they are symmetric with respect to the bisector of quadrant 1 and quadrant 3. So that is a very important conclusion. And this is not just true for f and g in question number 33. It is a general true fact. Okay, we are going to draw the conclusion. We're gonna write the conclusion right here in number 34. Any two functions, if the two functions are inverse of each other, their graphs are always symmetric with respect to the bisector of quadrant 1 and quadrant 3. You understand what is the bisector of quadrant and quadrant 3, right? This is the rectangular coordinate system. This is quadrant 1, 2, 3, 4. And the bisector of quadrant 1 and quadrant 3 is this dashed line. This is 45 degree. This is 45 degree. So we call this line bisector. It divides quadrant 1 evenly into half. All right. So the equation corresponding to the bisector is y equals x. Y-intercept is 0, 0. Slope is 1. Slope is 1, so the degree is 45 degree. All right. So the conclusion here, we need to know F and G are inverse of each other if and only if their graphs are symmetric with respect to the bisector of quadrant 1 and quadrant 2, or y equals x. Right? Here, if and only if both directions are true. If f and g, the two functions, are inverse of each other, then their graphs definitely are symmetric with respect to y equals x. Vice versa, if you have two graphs representing two functions, and they are symmetric with respect to the bisector of quadrant 1 and quadrant 3, then the corresponding two functions, the two graphs represent two functions, right? Then the two functions are inverse of each other. And we can look at the graph again. And if you turn your head 45 degrees to the right, okay, and still look at the screen, turn your head 45 degrees to the right, and you will see if you see the dashed line as the mirror, then F mirror G, G mirror F, right? Or if you flip F over the dashed line, you would have G. If you flip G over the dashed line, you have F. All right, guys, do you have any questions? The definition of inverse functions is the last topic we covered on Tuesday. And today we continue working on that definition, and we also have a conclusion drawn. The conclusion is about the graphs of inverse functions. The graphs of two functions that are inverse of each other are symmetric with respect to y equals x. So far, so good, guys? Some response?
Yep.
Yeah.
Okay,
Really
thank
good.
you. Let's see if we have more people join us. Okay, very good. So next, number 35. Given a function, find the inverse function of the given function. Since the goal of the problem is to find the inverse, that means the problem assumes the given function is invertible, or it is a one-to-one function. We have learned only one-to-one function has inverse function, right? Only when the function pass both vertical line test and the horizontal line test, it is one-to-one. One-to-one function does not have a cheating husband, does not have a cheating wife either. Every husband only has one wife, vice versa, every wife only has one husband. So here we focus on finding inverse function for a given one-to-one function. Let me show you how to do that. Okay, so if we are given f of x equals 2x minus 1, right? Yeah, let f of x equals 2x minus 1. Then we firstly replace f of x with y. Y equals 2x minus 1, right? And then we switch. Okay, I can write down the steps. Step 1, replace f of x with y. And in this case, we don't have to do that. But in general, if the function is given as f of x, the notation of function is given, then you replace f of x with y first. That's the first step. Step 2, interchange x and y. So in this equation, y equals 2x minus 1. We are going to write y as x. Yeah, everything else is the same. But when you see y, you write it as x. When you see x, you write it as y. Interchange x and y. When you see y, you write it as x. When you see x, you write it as y. Okay, interchange x and y. That's the step 2. Step 3, solve the resulting equation for y. Solve for y. Knowing this y is the original x, right? But now we are solving for the new y, solving for the blue y, okay? Solve for the blue y. And to do that, maybe I would consider switch the left side and right side of the equation. I have 2y minus 1 equals x. Solving the equation for y is to isolate y on the left side. And if I add a 1 to both sides, I have 2y equals x plus 1, right? You understand this? If you add a 1 to both sides, this 91 is cancelled, and you will have a plus 1 on the right side. Let me more space. Divided by 2, divided by 2, divided by 2, and we have a y isolated. We have a y. I'm gonna turn to here. Y equals x over 2 plus half. You can write that as y equals x plus 1 all over 2 as well. Or you can write as y equals half x plus half. All those three things, they mean the same. This is the same with this, the same with this. All right? And then step 4. Replace y with f inverse of x. So conclude f inverse of x equals half x plus half. And done. So the process, the general process to find the inverse function for a one-to-one function has 4 steps. If the function is given as f of x, like this, f of x equals 2x minus 1, the first step is to replace f of x with y. And then step 2 is to swap, interchange x and y. You're going to write y as x, write x as y. Step 3 is the key step. Once you have the new equation, after the x and y swapped, you're going to solve the resulting equation for the new y, And this takes a little bit of algebra ability. And then once you have y isolated, and you basically have the inverse function found, and then you replace y as f inverse, and f inverse is the inverse function of f. All right, f inverse is the inverse function of f. And if you have time and graph the two functions, you will see their graphs are symmetric with respect to the bisector of quadrant 1 and quadrant 3 as well. Anybody know what type of a graph this function f has? Function f is 2x minus 1. What kind of graph this function has? Parabola, or a hyperbola, or a straight line?
Straight line.
Yes, straight line. Very good. We learn this type of thing in Algebra 2, Foundation 2. Also, in Section 1.3, we reviewed some important thing about linear function, right? So this is linear. It's a straight line with a slope 2, right? Goes up, increasing. And its inverse is also a straight line, as you can see, with a slope half. And if you spend time to graph the two straight lines, you will see they are symmetric with respect to y equals x. And we are not going to do that here. I'll leave that for you. So that's the first question. The second question, number 2, actually I can insert a page breaker here. And this part should go here. All right. Number 2, same requirement. I actually meant we have f of x here, right? Yeah, we have f of x equals 1 over x plus 2. Function f is given. We need to find the inverse. Find f inverse of x. Let's follow the 4 steps. First step, replace f of x with y. So we have a y equals 1 over x plus 2. Very simple, right? Step 2 is also very simple. We are going to interchange x and y. Write y as x. Basically, you are going to write husband as wife. Write wife as husband. Just reverse the roles. And y becomes x and x becomes y. Everything else keep the same. And in the new equation, this is the new equation. With x and y swapped already, we're going to solve for y. And maybe I want to switch the order first. 1 over y plus 2 equals x, because we want to isolate the y on the left side eventually, right? So this step, I switch the left side and the right side. And then I minus 2 from both sides. And then the positive 2 on the left is going to disappear. Then we have a 1 over y equals x minus 2, right? Yeah. And how do we continue here? One way to do that is we taking reciprocal. Okay, I'm going to rewrite this equation as 1 over y equals x minus 2 all over 1. X minus 2 is the same with x minus 2 all over 1, right? Okay, so I just want to write both sides as quotient, as numerator and a denominator. And next step, I'm going to apply a treatment to each side of the equation. I'm going to flip the numerator and the denominator. In other words, I'm going to take the reciprocal of each side. On the left side, we have 1 over y. I take the reciprocal or flip the top and the bottom. I have a y over 1. I'm going to do the same thing to the right side. Flip top and the bottom. I have a 1 over x minus 2. And the y over 1, is just a y, right? We don't really have to write a 1 in the denominator. Then we have a y equals 1 over x minus 2. And we have a y isolated on the left side. Last step, replace y as f inverse. Then the original function, f, its inverse function, f inverse. We do need to know the notation. The notation is pretty straightforward though. If we are looking for the inverse of f, the notation for its inverse, you just need to put a -1 power exponent on the shoulder of f. If we are looking for the inverse for g, you just need to put a -1 on the shoulder of g. Okay? And what kind of graph those two functions have? F here is a hyperbola. You might remember we have a very simple basic function mentioned in previous section. This is called the reciprocal function. The output of the machine always equal to the reciprocal of the input. And the graph of this reciprocal function look like this. Yeah, I didn't mention this when we talk about the domain and range. So it has 2 branches, one branch in quadrant 1, the other branch in quadrant 3. And our function f is a daughter function of the reciprocal function. We just need to shift the black curve upward 2 units, right? Do you still remember transformation? So f is a hyperbola, okay? The graph of f is a hyperbola. And if you spend time to graph the function f inverse, you will see their graphs also symmetric with respect to the inverse, the y equals x, the bisect of quadrant and quadrant 3. And we are going to skip graphing the two functions. So when I send the paperwork to testing center regarding the calculator policy is you are allowed to bring any calculator with you. You can have a handheld calculator with you when you go to take the exam in the testing center. I think technically, since we have the graphing calculator in Lumen, the handheld calculator might not help a lot, but everybody is different, right? Maybe it helps you. You can just use either to double check. If you already have a graphing calculator, you can graph the two functions to see they're symmetric. They are symmetric. So far, so good?
Yep.
Okay, so this problem, number 35, covered the topic finding inverse function for a given one-to-one function. The process has 4 steps. You need to remember the 4 steps. You definitely have like a few questions like that, maybe 2 or 3 in exam 1 is to require you to find the inverse for a given function. All right. What is this one? Below is the table for the function f of x. Oh, same thing, find the inverse. I'm gonna skip those. And later when we have time, we're gonna go back, all right? We covered the 2 questions. All right, so I'm gonna skip 36 as well. I'm gonna talk about circles. Circles is the last section of this chapter, of this unit 1.8. You will have only 1 question about circle in exam 1, but in the homework assignment for 1.8, you have other topic you need to learn. Otherwise, you don't know how to solve the problem, right? So we're gonna do both. Let's look at number 38. Number 1, the standard form of a circle. Find the equation of the circle. Okay, so circle is one type of conic section. And graphically, circle is a geometric concept, right? Yeah, in the rectangular, we always consider a 2-dimensional space here. In the rectangular coordinate system, if you have a point, and you determine a distance, the distance is r, right? If you keep this distance and then fix the center and all the points that is r distance away from the center gives you a circle. So that's how do we describe a circle in geometry. And we are going to find the corresponding equation in algebra that could represent a circle. So we go from geometry to algebra. The equation of a circle has 2 forms, okay? Has 2 forms. The first form is called standard form. The standard form of a circle, let me write it down. The standard form of a circle is x minus h to the power of 2 plus y minus k hk square equals r squared. You need to memorize this equation. That 1 question in the exam, all it takes is to remember this formula, remember this equation. This formula equation is the standard form of a circle. You know, the important parameters determine a circle in a graph is the center and the radius, right? Once the graph has the center and the radius determined, the circle is certain. And what is the center? Where h comma k is the center. R is the radius. Radius is the distance between any point on the circle and the center of the circle. This is the center of the circle, the bigger red point, right? And this black point could be any point on the circle. The distance between any point on the circle and the center is the radius. And center has coordinates h comma k. And the graph looks like, we can use Pythagorean theorem to prove it, but I don't think that helps a lot. So I would just recommend you memorize the formula. X minus h to the power 2 plus y minus k to the power 2. H comma k is the center, equals on the right side, r squared is the square of the radius. Let's look at the first problem in 38. We need to find the equation of the circle below. The circle is shown here, right? And what is can we see the center of the circle? I think the center of the circle is 0, 0. Okay? Very obvious. 0, 0. It's because here is a positive 6. Here's 6. Here's negative 6. Here's 6. So that's how I know the center is 0, 0. That means h comma k, h is 0, k is 0. Anybody can help to find the value for the distance, for the radius, r. What's the value for radius? Radius is the distance between any point on the circle and the center.
6.
Yes, awesome, very good. By the way, center is not on the graph of the circle. Even center is an important parameter of the circle. But when we talk about circle, we only mean the points on this. All right, center is not on the graph, but center is important. Okay, very good. So we can find the equation. The equation would be h is 0, k is 0, so we're just plugging in h is 0, k equals 0, r equals 6. We have x squared plus y squared equals 36, and that's it. Pretty straightforward, right? One question, something like that in the exam. Number 2, we're gonna do the other way around. Number 1, we are given a graph of a circle. We write the standard form of the equation representing the circle. Question 2, we'll do the other way around. We are given the equation of the circle in the standard form. We determine the center and the radius, and we can graph it, right? So let's see. I'm going to write the formula again. X minus h to the power 2 plus y minus k to the power 2 equals r squared. How do we find the center? Is the radius easier to find? What's the radius? You only need to look at the right side. 6. Perfect. Very good. The radius is not 36, okay? The right side of the equation is a square of the radius. Square root of 36 is 6. Radius is always a positive, by the way. Radius is always a positive because it is a distance. Distance cannot be negative. What about the center? What about the center? Look at this yellow part. The two yellow parts.
It's 9, 6.
Yeah, we just need to take the opposites. Okay, we take the opposites of the two yellow parts. The yellow is a positive 9, and we take the opposite, negative 9. And then with y, we have a positive 6, we just need to take the opposite, negative 6. All right, always take the opposites. Because people have trouble to, some people struggle with the minus negative thing. Instead of struggle with that, just remember the number that add with x in the first parenthesis, its opposite is the x coordinate of the center. Similarly, the number that is with y in the second parenthesis, its opposite is the y value of the center. And once we have the center and radius found, we can graph it, right? I can quickly graph it. The center is -9, -6 in quadrant 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. And this is the center. How do you graph a circle, by the way? Manually, if we need to graph a circle, what I would do is find the center first for sure, right? And then go up 6 units. Why 6 units? Because radius 6, right? Go up 6 units. 1, 2, 3, 4, 5, 6, I would have this. And then go down 6 units. Go down 6 units would be here. And then go to the right 6 units. It will be around here. And then from the center, go to the left 6 units. Once we have those 4 points, it's very close, very close from drawing a very clean circle, right? It's going to be like that. Since the radius is 6, from the center, you go up 6 unit, go down 6 unit, go to the right 6 unit, go to the left 6 unit, you will find 4 points on the circle. And that would be very helpful for us to draw the circle. All right, so that is the standard form. The standard form of a circle. Standard form of circle. Last semester, it's kind of, I don't quite understand. A lot of students failed this problem. Even all it takes is just to remember the formula. Do not miss this problem this semester, all right? Number 4. So another form of the equation of a circle is a general form. What does a general form? What does the general form of a circle look like? So in the standard form, you can see we have 2 perfect squares, right? If we get rid of the 2 parentheses, and then we organize everything and move everything to the left side of the equation, then we would have the general form. I can show you an example. This is a general form. If the question tells you this represents a circle, right? X squared plus y squared minus ax plus 2y plus a equals 0 is the equation of a circle. And look at the equation. It doesn't look like the standard form at all, then that is the standard form. That is the general form. I'm sorry, I misspoke it. General form. All right. And the general form is not convenient. Standard form is very convenient because we are able to tell the center and the radius directly from the standard form of the equation of the circle. But from the general form, like this equation, we can't tell, right? Where's the center? Where's the radius? We have to figure out. Okay, how do we figure out? We need to rewrite the equation in the standard form. It is given in the general form. We need to rewrite the equation in the standard form. So kind of like a conversion. How do we do that? We need to use a technique. The technique is called a completing square. Completing square technique. It's pretty important technique in pre-cal. Let me show you how. x squared plus y squared. Any question? Minus 8x plus 2y plus 8 equals 0. All right? So this is the general form. Next, so how do I rewrite it in the standard form? I'm going to group. I'm going to write all the terms with x together. Okay, I'm going to write all the terms in x together and all the terms in y together. So I'm going to put x squared and minus 8x together and leave some space. And then put y squared plus 2y together. And we have a constant 8 here, right? And you know I'm going to move that 8 to the right. If you minus 8 from each side, this positive a will be cancelled. And you would have a negative a on the right side. When I teach Foundation 2, I teach a skill. It's called a transposition of terms. It says that we can move the terms around in the equation. So if we move a term from left side to the right side, like I move this blue term, I don't want the blue term on the left side. I want the blue term on the right side. I could just move it away, move it around, move it to the right side. But after we move it to the right side, we have to change the sign as well. If it was positive on the left side, it has to become negative on the right side. Well, you don't have to know that. If you know, it's going to be very efficient. If you don't know, it's fine. You just need to subtract 8 from each side of the equation to get that done. All right. So far, what we have done here is we grouped the terms with x. It's here, right? Put it here. And then we group the terms in y. It's right here. And then we move the constant terms on the right side of the equation. And then what do? We are going to complete square, right? We are going to complete square. We are going to add a number here. And we need to do the same thing to the right side because we are rewriting the equation. We are not changing the equation. Maybe we are only transform the looks of the equation. We are not, change the equation to a different equation. The equation has to keep the same. So I put a box here, means we are going to put a number, add a number in the box. To do that on the left side, to keep the equation unchanged, I have to do the same thing to the right side, okay? Similarly, I'm going to add a number. This is too thick. Change this thinner. Similarly, I'm gonna add a number behind a number with the terms in y, and to keep the equation the same, I'm gonna do the same thing to the right side as well. All right. Maybe I want to use a red color. The red color is more obvious. Okay, so basically now I added 2 boxes on the left. I also added 2 boxes to the right of the equation. The equation will keep the same because as long as I keep the same treatment to both sides, the equation will not be changed. All right, then what number gonna go inside the red box? What number is going to go inside the red box? The number is going to be in the red box. The number is going to be the square. It's going to be the square. Write it down, please. The square of half of the coefficient of x. The number we are going to put in the red box is the square of half of the coefficient of x. It's good if you remember it. Let's analyze, okay? What's the coefficient of x? What's the coefficient of x? That coefficient is a very basic concept in algebra foundation. Coefficient is the number associated with the variable. Multiply with the variable. What's the coefficient of x?
-8.
Awesome, thank you. -8, okay? And what is half of it? The coefficient of x is -8. What's half of it?
-4.
-4, very good, -4. And then we raise the -4 to the power of 2. What do we have? Excuse me. 16, right? We have 16. So the number we are going to put in the red box is 16. We're going to do the same thing to the right side. All right? Okay. I'll show you why. Why is 16? And in the blue box, we're going to put a number. And what number is going to go inside the blue box? The number going to go inside the blue box is the square. Same with earlier, okay? The square of half of the coefficient of y. Okay. Can you tell me what's the coefficient of y?
2.
Correct, very good. What's half of it? Half of 2?
1.
1. Raise 1 to the power of 2. 1 squared. 1 squared is still 1, right? So the number we're going to put in the blue box is 1. Same with the right side. Whatever we do to the left side, we have to do the same thing to the right side to keep the equation unchanged. Okay, now we are ready to complete squares, okay? Those 3 terms make a perfect square. If you have very good foundation from algebra, you know this is a perfect square trinomial. It's going to be x minus 4 to the power 2. I don't know if you can see it. Yeah, x squared minus 8x plus 16 is a perfect square trinomial you learned from algebra 2. And it can be factored as x minus 4 times x minus 4, right? 94 multiplied to 16 add up to -8. If you have extra time, you really should watch the videos I posted from my Foundation 2 class. A lot of things we learn in Foundation 2 is very, very essential to this pre-calc class. Okay, so the yellow trinomial can be written as a perfect square. Is a square of a binomial difference, x minus 4. And maybe this helps. This number is the half of the coefficient of x. -8 is the coefficient of x. Half of it is -4. All right? And get a different color, purple. Those 3 terms make a perfect square as well. Coefficient of y is 2. Half of it is 1. And those 3 terms, the 3 purple terms, are going to make a perfect square. Y plus 1. 1 is half of 2, right? 2 is the coefficient of y to the power of 2. And to the right, on the right side, we just need to calculate the numbers. -8 plus 16 plus 1. -8 plus 16 is a +8. +8 plus 1 is a +9. +9 is 3 squared. 3 squared. And left side, x minus 4 to the power of 2 plus y plus 1 to the power of 2. And this is the standard form. Once we have the equation in the standard form, we are able to identify the center and the radius directly. Can you help me to identify the center? How about radius? Radius first. Radius is easier. What's the radius?
3.
Perfect. It's 3, it's not 9. It's 3. Awesome. And what's the center?
4, -1.
Perfect, exactly. Use the opposite. You see the number that is with x? Just take the opposite of the number. This number with y, take the opposite of number. The center is Opposite of the blue, +4. Opposite of the blue, -1. That's the center. So H is 4, K is -1. And we can graph the circle. I'm going to skip that part. And you plot the center, go up 3 units, and from the center go to the right 3 units, from the center go down 3 units, and from the center go to the left 3 units. And those 4 points would help you draw a very good circle. I'm going to only cover rewriting a circle that is in a general form to standard form one time here. And mainly reason because you don't have this question in the exam. The question that is about circles in the exam is very straightforward. It's very straightforward. And you just need to memorize. All you need to do is to memorize the formula. All right, we have another 25 minutes. Do you guys have any questions about circles?
No, you're explaining it really well.
Okay, thank you. In section 1.7, there are 3 problems. It's actually the 3 problems actually about the formula for parabola. Since it so I'm gonna spend 15 minutes to talk about that. It's only 3 questions anyway. It's actually something about conic section. When you see parabola, we talk about 4 types of parabola. We only talk about parabola opens up, parabola opens down, and those 2 types are called a vertical parabola. And the parabola could also open to the right or open to the left. And those 2 types, we call them horizontal parabola. Horizontal parabola. And this problem number 37 gives a horizontal parabola. Because, how do we know? Because the formula for horizontal parabola is y minus k to the power 2 equals 4p x minus h. H comma k is the vertex. H comma k is the vertex. What is the vertex? Vertex is this point. Those points are vertex. And p here is the distance between the focus and the vertex of the problem. So every parabola has 1 focus and 1 directrix. The focus is always inside a cup. If we see parabola as a cup, and the directrix is a straight line below, under of the cup. And knowing this distance, the distance between, this is the focus. The distance between focus and the vertex, that is p. Also, the distance between the vertex and the directrix is also p. Yeah, this is a very giant topic. So the efficient way to cover that part and you don't struggle when you see something like that is let's go to Lumen and then work on those 3 problems, okay? Lumen 1.7, 7, 8, 9. Maybe we can do 1 or 2. Let me stop share and go to our Lumen. Give me 1 second. double share and share the Lumen, this one. Let me know, do you see Lumen here on my screen?
Yes.
Awesome, very good. So let's go to 1.7. 1.7. Yeah, it's give the inversion. Maybe because it's weird. It gave the 3 parabola problems in the reversion the inversion section. What is the teacher's review? Number 7. Yeah, something like that. You see that? How do we graph the parabola? We need to know the vertex. The vertex is 1, 3. Okay, in the parentheses, the number with x is -1. Its opposite is +1. So h is 1, k is +3. It's the opposite of -3. So the vertex, so this parabola opens to the right. This parabola opens to the right with the vertex 1, 3. 1, 3. So firstly, you find that. Oh, hold on. So we know this is gonna be a horizontal parabola. So you're gonna click here. This is a vertical. This is horizontal. If the square is on y, it is horizontal. So let's find the vertex first. Vertex is 1, 3, right? And then how do you graph the parabola? One way is to find another point, as you can see, based on the tool. How about you help me to find the x-intercept of the equation, this equation? How do we find the x-intercept? If we make y be 0 in the equation, then x would be the only unknown in the equation, and you solve the equation for x. Give you 1 minute. Can you help me to do that? Yeah, get your scratch paper and a pencil. Please plugging in y equals 0. I mean this equation, okay? This equation. I'm holding the curve. I'm trying to see where does the parabola cut x-axis. Now, wherever the parabola cross the x-axis, that is x-intercept. So we need to know the x-intercept. How do we find the x-intercept? We make y be 0. Make y be 0. It should not be too difficult. And what is x? Oh, hold on. I need to clear off. My vertex is 1, 3. I did it wrong. 1, 3 is here. 1, 3 is the vertex of the parabola. Horizontal parabola opens to the right. Yeah, when you plug in y equals 0, what do you have for x, guys? Pretty straightforward. I mean, very convenient. What is x? Okay, you want me to do that? Okay. Let's do it together. And I have to stop share that and share a different one, different app here. So we are going to find a x-intercept to find the x-intercept, make y be 0 in the equation. Okay, let's plug in y equals 0. So we have a y minus 3 to the power of 2 equals 9 times x minus 1. Y is going to be 0. 0, right? 0 minus 3 is negative 3. Square of negative 3, a perfect square will never be negative. So negative 3 times negative is positive 9. Okay, positive 9. And then divide each side by 9. You have 1 equals 9 over 9 is also equals 1. You have x minus 1. Since x minus 1 equals 1, put it here. And then plus 1 plus 1. What is x equal to, guys? Is x equals 2. So the x-intercept is 2, 0, right? Yeah, you need to be able to do this part. X equals 2. So let me stop share this one and share our lumen. Share our lumen. Where is it? It's here. Okay. All right, so you click this horizontal parabola graphing tool, and then you plot the vertex, which is 1, 3. The first component is x coordinate, right? The second component is y coordinate. So 1, 3 is right here. And then the x-intercept we got is 2, 0 right here, 2, 0. There we go. That's the problem we're looking for. Check. Is correct, right? You can do another one. And this one is the same thing. When you see the equation in this form, the equation gives a horizontal parabola. But this time the parabola opens to the left. The reason we know is open to the left is because there's a negative here, negative 1/3. Earlier, this one is positive, so open to the right. And what is the vertex? What is the vertex? X minus 1 in the parentheses. Opposite of minus 1 is positive 1. 1 minus 3 in the parentheses. Opposite of negative 3 is positive 3. So the vertex also 1, 3. But this time open to the left, right? Okay, I want you to help me to find the x-intercept. Make y be 0. Help me to find the value for x. Do what I just did earlier. You know what? I changed my mind here. So because I saw that this parabola cross the y-axis, this time help me to find the y-intercept. This time help me to find the y-intercept. Okay, we can do it together. This time find the y-intercept. Share my note, my OneNote here. My OneNote. All right. This time, I want y-intercept to find the y-intercept. We understand what is y-intercept, right? Y-intercept is the intersection of the graph with the vertical scale, y-axis. Make x be 0. So we're going to plug in x equals 0. So the equation is y minus 3 to the power of 2 equals 1 over negative 1 over 3 times x minus 1. This time we're plugging in x equals 0. 0 minus 1. 0 minus 1 is just a negative 1, right? Y minus 3 to the power of 2. Negative 1 over 3, this is negative 1. Y minus 3 to the power of 2. Negative times negative, positive. We have positive 1 over 3, right? And so now we have y minus 3 to the power of 2 equals 1 over 3. We're going to take the square root. We have y minus 3 equals plus minus root 3 over 3. And y equals 3 plus minus root 3. Not convenient. Okay, I changed my mind. Let's see, what do we want to have? What if we plug in 4? Okay, what if we plug in 4? Let's see what we have. Trial and error. We already have the vertex. We just need one more point. What if we plug in x equals 4 to see if we can have a point on the graph with convenient components? So y minus 3 to the power 2, negative 1 over 3, x equals 4, 4 minus 1. 4 minus 1 is 3, right? Negative 1 over 3 times positive 3, negative 1. Doesn't work. Negative 2. How about let's plug in negative 2? Should be better. Negative 2 here, so we're gonna negative 3. Negative 3, then we have positive 1. Okay, this would work. Then y minus 3 would equal to 1, or y minus 3 equals negative 1, right? Yeah, how do I know plugging x equals negative 2? As you can see, I did not know. I tried the two intercepts, but not convenient. It's hard to graph a irrational number or fraction. I want whole numbers or integers. So I try negative 2. If we plug in x equals negative 2, in the parentheses, we have negative 3. And negative 3 is the reciprocal of negative 1/3. So we have 1 on the right side. That's very convenient. If y minus 3 to the power 2 is a positive 1, then the base y minus 3 is either equal to 1 or negative 1. So here we have a y equals 4 or y equals 2. All right, so the 2 points we have is negative 2, 4 and negative 2, 2. We got 2 points. Negative 2, 4 probably is enough. Let's remember those 2 points we got on the graph. Negative 2, 4, negative 2, 2. Let's go back the lumen. Go back lumen. Which one? This one. Is a horizontal parabola. So again, we click this, select this icon is a horizontal parabola. The vertex is 1, 3, 1, 3. The parabola opens to the left, so it across y-axis. But you know, we tried y-intercept is not convenient. But we found a negative 2, I forgot already. Negative 2, 2 and negative 2, 4. You see that? This is negative 2, 2. Here is negative 2, 4. It works. All right. Next one, same thing. Did I already?
How
I'm
did you
sorry?
get negative 2, 2?
I'm sorry.
How did you get negative 2, 2?
Yeah, negative 2, 2 and negative 2, 4. I couldn't
Negative
really.
2 was the x that she plugged in the equation. Sorry, I'm sick. And then she solved that to get y, which was 2.
Maybe.
Oh, I understand what you're saying. I did try to plug in x equals 0, right? But the y values is irrational. Like root 3 is not convenient. So I tried, like try and error. I tried to find negative 2. Yeah, find the negative 2. Because if we plug in negative 2, we have the corresponding y value 4 and 2, very convenient. The coordinates of those 2 points are just integers. Let's do one more. I think I did this some other time. I'm gonna erase, clear all, okay. This one, since the positive, the parabola open to the right is horizontal again. The vertex is easy to find. it is 2, 1, 2, 1 to the right? So I would try the x-intercept. Let me do that quickly. Yeah, that works. Okay, can you help me to plugging in y equals 0 and let me know what's the x-intercept? I'll let you to do this part. Plug in y equals 0 to get the x-intercept. Plugging in y equals 0. Plug in y equals 0 and solve for x. What's the value of x?
Six.
6. Correct, 6. So we know the parabola passing through 6, 0. There we go. Right? I think you only have 3 problems regarding horizontal parabola graphing and knowing how to find a vertex. Once you have a vertex, you only need one more point to graph the parabola. This is the assignments we have from the department. Maybe there's a reason we have this type of problem in this section. Okay, we have 5 minutes. Let's talk more about the inverse function. My note, this one. Okay, let's work on this problem. Okay, the reason is because this problem is very similar with a problem in your exam, finding inverse. By the way, this is a hyperbola. You don't have to know that. It is 1-to-1. So let's see, I'm going to insert page breaker. Okay. We need to find f inverse x. Step 1, rewrite f of x as y. We have y equals -8 over -5x minus 3. Step 2, interchange x and y. Write y as x, write x as y. Step 3, solve this resulting equation for y. Okay, let's see how do we do that. I'm going to use the same strategy with earlier. And left side of the equation, sometimes when I solve the equation, I'll draw the line here, like an imaginary line, to separate the left side and right side of the equation. So left side, I'm going to write it as a quotient, x over 1. Right side is already a quotient, -8 over -5y minus 3. And then I'm going to flip left side and flip the right side. Left side, flip top and the bottom, 1 over x. Right side, flip the top and the bottom, we have -5y minus 3 all over -8, right? And I have a question. So look at this expression, -5y, -3 all over -8. This type of expression, the structure of the expression is very common in pre-cal. It has 3 terms, left ear, right ear, ahead. Do you see a Mickey Mouse? When you have a quotient, 2 terms on the top, 1 term on the bottom, you'll see a Mickey Mouse. When all the 3 parts have a common factor, you can get rid of the common factor. As you can see, the left ear is negative, the right ear also negative, the head is also negative. All the 3 parts are negative. Why don't we just, get rid of the negative altogether? So positive, 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 right? positive A. And then by flip the top and the bottom, we have the y on in the numerator on the right side of the equation. And then we're going to switch the two sides. Switch the two sides. I have 5y plus 3 over 8 equals 1 over x, right? And then we're going to multiply each side by 8. Multiply each side by, multiply each side by 8 over 1. Because I want to cancel the denominator 8 by 8 over 1. Then the left side, we have 5y plus 3. The 8 is cancelled, right? On the right side, we have 8 over x. 8 over x. And then subtract 3 from each side. We have 5y equals 8 over x minus 3. And then divide everything by 5. Divide 5. Divide by 5. Okay? Once you divide by 5, the left side has y isolated. On the right side, again, we see the structure, the Mickey Mouse structure, right? We see the Mickey Mouse structure. Left ear, right ear, and a head. And we are going to apply the same treatment to all the three parts. We are going to multiply x. Left ear times x. Right ear times x. Head times x. Then the left ear, the 2x will be cancelled, right? And the numerator would become 8 minus 3x. Denominator would be 5x. Last step, switch y to inverse, f inverse of x. And that's how do we find the inverse. I think you're going to see something similar in the exam. So I include this problem in the guidance note. When we review, we will review a similar problem again. This one is a challenging one. It takes a lot of algebra effort. When you go to higher level mathematics, the idea actually not like I cannot say not challenging, but the idea is pretty simple. Once you get it, it's pretty simple. What is really challenging for some students is the still algebra part. Like this idea to find the inverse function, all you need to do is to follow the 4 steps, right? Step 1, 2, 3, 4. But when you apply the 4 steps, it takes a lot of algebra, solving equation, right? Multiply, divide. And that part actually is the challenging part. Okay, we ran out of time. I think we covered everything important in this unit. Next Tuesday, we are going to review for exam 1 and look at the announcement I posted recently. You should also have an email informing you the same content. Time and the location is in the announcement. And if you are in high school, I'm working on arrange your exams in your high school as well. Give me some time. All right. Thank you guys for coming. If you have any questions, feel free to email me. I'll see you on Tuesday.
Excuse me. I don't know if you take math. Did you mark me present?
Yeah.
Oh, okay. Okay. Just
Yeah.
want to be sure.
Yes, Ether. Yeah, I see you here.
Okay. Thank you.
I joined late. Did you get me down on the attendance?
Can you email me? Then I can fix the attendance later. Yeah.
Okay.
If you miss attendance, please remember to email me and I can fix your attendance later. I just really don't want to do it in the middle of teaching. I don't really want to do that now either. So please email me. All right, guys. Thank you. Bye bye.
On the
Thank
review
you.
that you
Bye.
sent out, sorry, on the review that you sent out, was it supposed to have all answers on it or no answers? Because I
No
looked at
answers.
it, like I glanced at it, and like some of them have answers to them.
Oh, some of them do. Probably because I already did it in the system. Yeah. Some of them did have the answers. They are not supposed to have answers. On Tuesday, next Tuesday, we are going to work on those problems and you will have the answers.
Okay.
All right. Okay, guys. See ya. Bye-bye.